Hello, today we are going to see about CISC, RISC, characteristics, advantages, disadvantages, differences, everything. So first let us see what is RISC pipelining, RISC and CISC. RISC is nothing but reduced instruction set computers. So here reduced instruction set in the sense the instructions are set in such a way that one instruction per clock cycle it is executed. It is so simple, simple to execute, simple to understand, simple to implement also. Whereas CISC if you are taking it is more complex. The name also you can say complex instruction set cycle. So in complex instruction set computers more complexity is increased. That means more than one cycle is required, more than one word is required to store and a complex way the designing of the instructions that are made. Both the approaches whatever you are taking they try to increase the CPU performance. That is the reason why we are going for this. So now let us first start with RISC, reduced instruction set architecture. So here the main idea it is to simplify the hardware by using an instruction set composed of few basic steps for loading, evaluating, storing etc. A single instruction for each and everything, single one we are having. So characteristics of RISC if you are taking, it is simpler instruction as I told you. Hence simple instruction decoding will be done, while decoding also it is simple. Instruction comes under the size of one word, one instruction within one word you can store that. Instruction takes single clock pulse for the completion of the execution. More general purpose registers are used for this and simple addressing modes are used. Fewer data types they are included for this RISC and a pipeline can be achieved for this RISC technique. Advantages of RISC if you are taking, as I told you it is simpler instructions. So RISC processor it used smaller set of instructions which makes easy for the decoding and easy for the implementation purpose. The result in fast processing times it will be done and faster execution. As you are having simpler instructions it is easy to decode, easy to execute. So obviously the execution will be done in a fast mode and lower power consumption. So as it is simple it consumes less power than the CISC processors. So it is ideal for portable devices if you are using the RISC it is ideal for use. But there are some disadvantages also. Disadvantage if you talk about more instructions are required because simple instructions when you are doing obviously the program will be lengthy. So more number of instructions are to be used and increased memory usage. So definitely when we are having small things when we are storing and going more memory is required when compared to CISC and higher cost for developing and manufacturing the RISC processors it will be more expensive than the CISC processors. Now let us see this complex instruction set architecture that is CISC. Here the main idea is that it is just opposite to RISC. In RISC simple instructions we are doing. Here we are dealing with the complex instructions. Complex instructions in the sense but in the programming part if you are taking for example multiply. So multiply is a single statement but for that multiplying we have to take the data, we have to load the data, we have to execute it and we have to store the output in some register or some memory place. So that means though a single thing it is given when we are executing it is divided into pieces and in a lengthy manner it has to be executed. So it is a bit complex. Coming to characteristics of CISC. So CISC complex instruction obviously when the instruction is complex decoding also will become complex. Instructions are larger than one word. So it depends on the instruction and sometimes we may require more than one word to store the instruction. In CISC instructions may be more, it may take more than one cycle. So, it may not be possible that all the instructions which we use in the CISC, they will be completed within one time cycle, whereas RISC, it will be completed within one clock pulse. Here less number of general purpose registers for operating is performed in the memory itself. So, here obviously complex addressing modes are required, because though you see the instruction is very small, too many things are to be included in the instruction. So, addressing modes also, complex addressing modes are used. Same way more data types are used. So, it is in RISC we are having the simpler data types, but here more data types are used to implement the CISC. Coming to advantages, here we are having reduced code size. So, as the instruction, within the instruction it is complex and too many parts we can include in that. So, less number of instructions are used. So, here the code size, if you are taking, that code size will be obviously reduced. More memory efficient. So, less number of code, now less number of instructions are included. So, much memory is not required. A few instructions to be performed, few instructions are to be stored. So, less memory is required. So, more memory efficient. Widely used. Generally in latest systems, if you are taking whatever the systems now we are having, CISC processors are in use for a longer time than RISC processors. So, because they are having the large user base and more available softwares using the CISC. But here also we are having the disadvantages also for CISC, slower execution. So, simple commands if you are giving, it is easy for the execution. When you are giving the instruction itself, it is complex. So, the execution also it is a bit slower. It has to, the complex instructions, it need more time to decode and to get the execution. So, designing also it is more complex, because it has to handle the complex instructions. Higher power consumption, more power is consumed for CISC compared to RISC. Now, let us take a 3-segment instruction pipeline. So, now we are going to see how this pipelining is done. So, from the starting we are seeing that pipelining means any operation, any process, it is divided into subtasks or sub operations. So, it depends on how many segments we are going to divide. Here we are going to take a 3 segments instruction. That means one instruction, it is divided into 3 segments. What are the 3 segments? Instruction fetch, ALU operations and execution instruction. So, instruction fetch we are representing as I, ALU operations we are representing as A, and execution we are representing as E. The same thing it is given here. I is the instruction fetching the instruction, ALU fetching the instruction, that only it is including the decoding and ALU operations which are performed. So, ALU 3 different functions depending on the decoding of the instruction, data manipulation instructions, effective address, then storing the instruction, calculating branch address, everything it comes in the ALU operations only. And E segment, the output. So, when you are having an output, there are different destinations where the output is to be stored. It depends on the decoding of the instruction where we are going to store the output. So, it transfers the result of ALU operation to the destination, that all thing you are having in the E. Now, for example, suppose consider the operation in the following 4 instructions. First instruction is you are taking the content from the given address of the memory and storing in register R1. That is one instruction. Taking the content of some other address from the memory and storing in register R2, that is instruction 2. You are adding the contents of R1 and R2 and storing the output in R3, that is instruction 3. Now, in R3 you are having some value, the content of R3 you are storing in some address in the memory which is given as address 3. This is instruction 4. So, 4 different instructions you are having. So, now if you are taking the difference between pipeline timing with data conflict and pipeline timing with delayed load. So, delayed load if you are taking, data conflict will not be there. So, here 4 instructions, you are starting with instruction 1 load R1 in first time cycle. In second clock pulse already it is fetched, instruction is fetched. So, here you have to ALU operations you are performing here in the second clock pulse. Whereas second instruction load R1 fetch the instruction part you are doing. And here R1 plus R2 fetch the instruction part you are doing, and here you are doing the execution part, ALU computing part you are doing here, but this overlapping is there. So, here if you are taking one cycle or one level with no operation, we are delaying. Why we are delaying? Since this execution part is over, we cannot use that here. So, till we complete the execution part, we are delaying the third step, and then we are doing add R1 and R2. That is why here we are having 4 steps, 4 instructions, here also 4 instructions, but in between we are having one no operation. So, this is with delayed load. All this is the 3 segment pipeline timings. Now, let us see the difference between RISC and CISC. Already characteristics we have seen. So, CISC, a large number of instructions, from 100 to 250 instructions it can carry. That's CISC, as it is the complex, and relatively few instructions will be there in RISC. Some instructions perform specialized tasks and use infrequently in CISC. Here relatively few addressing modes are used in RISC. A large variety of addressing modes are used, 5 to 20 maximum it is used in CISC, whereas here relatively few addressing modes are used. Variable length of the instruction format. So, here length of the instruction format if you are taking, generally fixed length in the sense whatever the length you are taking to store the instruction, that will be same. That is the reason that here it is limited, and within one word you can fix the instructions. Here as you are having variable length, you cannot decide that only one word you can fix the instructions. Sometimes it may be necessary that more than one word you are using. Here instructions that manipulate operands in the memory. So, here if you are taking, all operands are done within the registers of the CPU. Memory access is limited to load and store the instructions only. Fixed length, here variable length, here fixed length we are having, and single cycle instruction execution. As I told you, in CISC it may take more than one cycle to complete the execution of the instruction. Here single cycle instruction execution is done, as the instructions are simple, and here hardwired rather than programmed control, it is given in the RISC characteristic. Now, let us see one example. Suppose we have an operation A is equal to B plus C. So, that A is equal to B plus C, in RISC how it is given and in CISC how it is given. In RISC, as I told you, each and every small operation it is given as an instruction. So, here A is equal to B plus C, if you want to perform, what are the steps that are required? First, B value is to be taken, it is to be stored in some register. C value is to be taken, that is to be stored in one register. Now, the contents of these two registers you are performing the addition, then the result is again stored in one register. Now, after having the register content which you are having the output, that is to be stored back to the memory space. These are the steps involved. So, in RISC, as I told you, simple manner the instructions are designed, each and every step you are having one instruction. First, load B R2, that means nothing but the value of B is taken and it is stored in the register R2. Load R3 C, the content of C is taken and loaded in R3 register. Now, add R2, R3, R4, in the sense you are adding the content of R2 and R3 and the output it is stored in R4. Now in R4 you are having output that you have to store back into A, store R4A. So this the same instruction it is given as 4 instructions to execute in RISC processor. Whereas CISC processor, if you are taking the same instruction within 2 statements it is executed. Move A comma B, add A comma C, that is all. Move A comma B means we are moving B value to A, add A comma C. First we are moving, we are storing the content of B to A, then adding the content of C to A. In A already B value is there, to that we are adding C value, that is the result. So the same statement if we are executing in CISC processor, within 2 simple steps we are going to complete the execution, whereas RISC processor 4 simple instructions are used to execute the same instruction, same set of operation. Now let us see the pipeline performance. So in pipeline performance, the main thing is, the main advantage is to improve the speed of the performance. So for that, how we are calculating, using pipeline, not using pipeline, how we will be calculating, that we are going to see here. So here what are the things that we are going to consider to calculate the performance? K stands for segment. TP stands for time pulse or clock cycle or clock pulse, whatever you are taking. N, number of tasks which you are performing. T1, K into TP. K is segment and TP is clock pulse. That too if you are multiplying, that is T1. The remaining tasks if you are taking N minus 1 into TP. So total performance when you are calculating, it is K into TP plus N minus 1 into TP. So this one if you are simplifying, TP common you can take, K plus N minus 1, that you have to calculate to calculate the performance of the system. In non-pipelining if you are taking, Tn is time, N is number of tasks, total time is N into Tn. Speed up ratio if you are taking, time for non-pipelining divided by time for pipelining. What is the ratio if you are calculating? S is equal to N into Tn by, for pipelining what you have taken? For pipelining the performance is Tp into K plus N minus 1. So K plus N minus 1 into Tp, this one is N into Tn. So as number of tasks increases, N as it is increasing, the speed up ratio will be increasing. So speed up ratio is nothing but number of tasks. So this is a comparison between the performance when you are using the pipeline and when you are not using the pipeline. So let us take one example and explain the same thing. Suppose Tp is equal to 20 nanoseconds, Ns is nanoseconds, K is equal to 4, N is equal to 100. Now let us calculate the speed up. So speed up ratio is nothing but time for non-pipelining divided by time for pipelining. What is time for non-pipelining? N into Tn. Time for pipelining, K plus N minus 1 into Tp. So here K plus N minus 1 into Tp if you are taking, K is 4. 4 plus N is 100. 100 minus 1 into 20. Tp is 20. So it is total of 2060 nanoseconds. Non-pipelining if you are taking, non-pipelining is nothing but N into Tn. First let us calculate Tn. Tn is equal to K into Tp. K is 4, Tp is 20. So 4 into 20, 80. N into Tn, N is 100, Tn is 80 is equal to 8000 nanoseconds. So that means for non-pipelining it is 2060 and for pipelining, using pipelining it is 2060 and non-pipelining it is 8000. So what is the ratio? S is equal to 8000 by 2060 that is equal to 3.88, that is approximately 4. 4 is the 4 times it is speed up. For using the pipelining and not using the pipelining, the speed up process if you are taking in this example, it is 4 times it is better than not using the pipelining.